Today we're going to build off of our spaghetti graphing from yesterday and take a look at graphing the sine and cosine. So yesterday, whoops, that didn't work out very well. Let's try that again. Yesterday our graphs, we could say that there were key points here, and whether it was sine or cosine. We had our midpoints, we had a low point, and we had a high point. And we know that these came, if we were looking at sine, these came from our unit circle. For example, our sine here is, if we were to label these coordinates, 0, 1, negative 1, 0. And if we were to look at our sine values here, it starts at 0, so here's our 0. Then it goes to 1. Then it goes back to 0. Then it goes down to negative 1. And then back to 0. So it was measuring kind of the height as we travel around the circle, what's happening to our heights here. And we had all those triangles drawn in with our heights. So there were these key points there. A lot of times they're referred to as your critical points. So a sine and cosine are periodic, which means it repeats itself, because these waves would keep going on and on forever, because when you think about it, our circle, if our height, it keeps going around and around. So if we were talking about that height here in all the different spots, those heights, they just keep repeating ourselves, and our cosines, that width, the widths keep repeating themselves as well as we go around the circle. So the period is how long one cycle is. And now we don't always see our sine and cosine curve as just y equals the cosine of x. Oops. Our period, we'll see it as y equals a, the sine of maybe, oops, not 2x. I'm going to put a b right there. And y equals a times the cosine of bx, because these shift as well. So our period, it's typically 2 pi around a circle, but we're going to divide it by whatever that b value is. So first we're going to take a look at our regular sine and cosine. So let me see, I think I got ahead of myself a little bit. I did. We'll get back to that in a second. Sorry, guys. So what usually happens in our circle here? Well, here are our critical points. So we have pi over 2 up here, pi, 3 pi over 2, and 2 pi, our degree measurements. So we can go pi over 2, pi, 3 pi over 2, and 2 pi. So we have negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. And where does our sine start? Well, again, 1, 0, 0, 1, negative 1, 0, 0, negative 1. At our start, it is at 0. At pi over 2, our y value, our sine, it goes up to 1. It goes back to 0. Then down to negative 1, and back to 0. So I should label these 1 and negative 1. So we have this curve, and it would just keep repeating itself and going backwards. Negative pi over 2 is at negative 1. Then it goes back to the middle, high, middle. So we have our lovely sine curve there. So properties of this sine curve. The period is 2 pi. Well, that makes sense all the way around the circle. The domain is all real numbers, meaning we could have any angle, we could find the sine there. Our range, our high and low, negative 1 to beginning, to positive 1, excuse me. Our x-intercepts are at the beginning, end, and halfway through your period, because when you think about our x-intercepts would be right here when the sine is 0, and our y-intercept is also 0. So what does our cosine look like? Well, we have that same circle here. 1, 0, 0, 1, negative 1, 0, 0, negative 1. But we are graphing our x value, our cosine. So this is the same thing. We got pi over 2, pi, 3 pi over 2, and 2 pi. negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. So our cosine, though, is our y or our x value. So it starts at 0 degrees, it's at 1. Pi over 2, it's at 0. At pi, it's at negative 1. Then it goes back to 0. And it would go back to our starting. So we have 1 and negative 1. And then let's see, it's at 0, negative 1. It follows that pattern. And again, these are curves here. A lot of times people like to write these as straight lines, but these are curves. Oh, and workspace crashed. We'll see if we can bring it up again here. Hopefully. So we're going to take a look at some of the transformations on this. First we're going to look at some properties. Sorry, guys. And again, you can see this from the graph. The period is 2 pi. Again, we can domain as all real numbers. And again, that means we can use any angle. Negative 1 to 1. The x-intercepts change, and our y-intercept is 1. Now the amplitude is how high it goes. So it's not always going to go to 1 or negative 1. This value before will tell us how high it goes, and our amplitude is always the absolute value. We'll talk about what a negative does. A negative gives it a reflection there. The period is how long one cycle is, and I guess they're going to use k here, but it's that number before the theta, so 2 pi over k. So we're asked to state the amplitude and period, then graph it. Well, our amplitude is 1/2, and you know what, we might just, let me see if I can move this up a little bit so we can see it. There we go. Otherwise you couldn't see the bottom there. So our amplitude is 1/2, and our period would be 2 pi over 4, or pi over 2. So we know that if we start at 0, we're going to come back to it at pi over 2. So this one has to be pi over 2. But, well, how do we label all these other marks? Well, this is halfway, and this is a fourth. So to find our scale, what we're going to count by, we're going to take pi over 2 and divide by 4. So pi over 2 times 1/4 of that. So we have pi over 8. So this is really 1 pi over 8, 2 pi over 8, which is pi over 4, which makes sense because it's half of it, and 3 pi over 8. And I'm going to assume, you guys, we don't have to go backwards here. So this is, our height goes to 1/2 and negative 1/2, our amplitude. And our sine, this is where people always get messed up. Where is it going to start, at the high point or in the middle? Well, our sine here, it's usually 1 and 0. So this is 0, 1 and 0. Our sine always starts at 0 there because that's our y value. So it would go here, then it goes high, middle, low, middle. And then we could fill in this back half. It's going to go low, middle, high, middle. So this next one here, write an equation for a cosine function, and we're given the amplitude and period. So y equals a times the cosine of k theta. Well, our amplitude is 9.8, but that k, well, we know our period is 2 pi over k, but we know our period is 6 pi. So 6 pi equals 2 pi over k, multiply by k. So we have k times 6 pi equals 2 pi, and we can divide by 6 pi. So k equals 1/3. So this is the cosine of 1/3 theta. So let's say we have to graph this one. Well, our graphs, we're going to graph a period on each side. So 4 marks out on each side. Our amplitude equals 2. our period would be 2 pi divided by 2, which is pi. So we know 1, 2, 3, 4. This is going to be pi and negative pi. Well, our marks, our scale, we have to divide it by 4. So it's pi over 4. So this is 1 pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4. So 2 and negative 2. And then we have to decide, where does our cosine start? Well, which value is our cosine? Well, it's the x, so it usually starts at 1, but in this case it's going to start at 2. So high, medium, low, the mid, the high, mid, low, mid, high. And we have our cosine curve.